Okay, hello everybody. Thanks for coming. This is the Lab 9 for the Cruise Data Science Initiative. We're going to be talking about impact analysis and how the pandemic impacted the oil industry. So this is going to be our last lab of the year, and they're going to be returning sometime in January. So I'm going to just start sharing my screen, and then we can start. So this is the presentation for today. Are going to be talking about impact analysis in R. It's going to be a hands-on webinar. You're going to understand the effects of the COVID-19 pandemic to the oil industry, and it's going to be presented by me and by Daniel Thread. So just an introduction for the hosts. My name is Marcelo Guarido. I'm a data scientist with PhD in geophysics, and I'm the head of the Cruise Data Science Initiative. Daniel?
Yeah, I'm Daniel Trad, and I am a professor at the university and work with Marcelo in this cruise machine learning initiative as well.
Okay, thank you, Daniel. So just starting, just telling you what is the Cruise Data Science Initiative. So it's a new initiative inside Cruise. Cruise is a consortium that is located at the University of Calgary that has a long history working with seismic data. And now we are starting to do those data science projects. And they're going to be doing projects that are related to the academic and the industry. Most of our projects are going to be geoscience, but you're going to be doing other type of projects as well, such as engineering, safety, and whatever we have. Also, we provide some programming trainings in R, Python, and MATLAB. Could be just introductory ones, as well could be something more applied to your work, to your data set, and related to the data science road, and also how to create applications that you can um, create a website or something like that. And also, we provide those learning labs, those labs that we present every 2 weeks. Those are free webinars where we're going to be talking about different applications and projects. Most of those projects are POC. And you can access also the previous information about the labs in the Cruise website. So I'm just gonna click in here. So in the cruise.org website, if you come to the tab research link, we have this data science tab. And here you can access the videos and the codes for the previous labs. Like the last one that was 15 days ago, we talked about the time series forecasting with Arima and how to predict to do forecasting of the COVID-19 pandemic on different countries. And most of the codes are in R. We have a couple of them done in Python. So just returning to the talk. Well, today we're going to be talking about the pandemic and how it was the impact to the oil industry. So first, let's talk about the pandemic. Just remember the timeline. There is this nice website from the WHO. That is the response timeline. And they have this app in here where you can go and click and see the response of the WHO. I'm just going to show the website for you. So it's this one. So you can see what happened on each one of those days. You just click in the action. So WTO's had the first response for a viral pneumonia in Wuhan. So, and here we start to see all the number of cases daily and how things starts to grow. So sometime in March, I think it was March 11, it was declared as an official pandemic in some point in here. So just going back to the presentation, a little bit of the timeline of the pandemic. So the first case registered that we know until now was in China, and it was tracked down to December 8th in Wuhan. So the first case outside China was in January 13, 2020. It was in Thailand. And then we had the first case in the United States that was January 21st. It was in Seattle, a person that was coming back from Wuhan in the travel. And then in January 23rd, we had the first confirmed case in Europe that was in France. Um, the January 25, the first case in Australia. And the February 14th, it was the first case in Africa. So that was when officially it was in basically all the continents, all the Americas, all the Europe, Asia, Oceania, Africa, every place. And then WHO declared as a global pandemic on March 11, 2020. A nice app to register to always keep looking and tracking how the pandemic is going is this Johns Hopkins University COVID-19 map. As for yesterday, we had 56 million confirmed cases around the world, with 1,348,000 deaths confirmed. I always say confirmed because many countries also have problem by confirming cases by doing tests. So those numbers could be actually lower of the reality. So we always have to be taking care. We can even look to the website. We can see the numbers today, basically. So this is the website for the COVID-19. I'm just going to refresh here. Okay, so it's just loading the map and everything. So we can see the cases by country. We can see deaths, the recovery for the US more specifically. Uh, Still loading everything. They must be uploading the cases, so don't worry. Um, it's quite slow today. So you see here, for example, for countries, the number by country. So you see that the US is the country that has the largest amount of cases, followed by India and Brazil. And Europe, we have France with the largest number of cases. So this is the map. We can click and see how it was spreading around the world. So apparently Africa is being less affected. Uh, I would say proportionally speaking, or relatively. So you see India has a high number of cases and so on. So the COVID-19 is a type of disease that is spread by the air. So it's a respiratory kind of disease. So we always have to take care going to places, wearing masks, washing your hands, and going to places where we have other people gather. So I'm just going to talk a little bit how was the oil industry for this year. It's just one slide showing the how was the price in the 2020 for the just United States that you're doing this analysis. So this is the WTI crude oil pricing. So it was how it decreased in 2020, mostly because of the COVID-19 pandemic, but also other factors. But we are gonna just coming with the hypothesis that the only factor for the decrease in 2020 was the pandemic. So that's what happened in 2020 for the price. We even had one day here that was negative. You're gonna see that. And also the production. We had a big drop in production also due to the pandemic. Um, so our goal today that you're gonna be studying, you're gonna be doing forecasting of what should be the price without the pandemic and what should be the production without the pandemic. So we are just going to get the past of the 2020 and try to predict how should be. And then we can calculate impact analysis, knowing what should it be and what it was. So we're going to be using a library in R named model time. That it's a very powerful library where we can do forecasting using different methodologies. So I'm just going to click here. It's going to open the website. So to using R, just install model time. I'm just going to make it a little larger. And it works on forecasting. So you can select different type of algorithms like Arima and ETS, the Prophet Facebook. You can use boosted trees, regression. You can use neural networks, support vector machine. There are different ones that you can use to do the forecasting. We're going to just focus on a few ones, and they're going to show you how it works. Oops, should go to the presentation. Oh no, yeah, let's go code. No, it was right. So this is my RStudio environment. The codes are going to be provided for you after this session. So everything that you're going to have is this R project. It's just the project in R that we save all the environment in here and all the information that you're using for this code. And this lab9 impact analysis.r. So this is this R file that it's opening in here. And a few things that we might need to set for you. It's a quant-L. This is a library where you're going to be downloading all those APIs or all the data about the production and the price. So I'm just going to copy here and show the website for you. So this is the quant-L website. You can come and log in here. I have my account. And whoops, I shouldn't come here. It's being recorded. I might have to cut this part. So you have to set up a key so you can download the data from here. And you can search for the coding of the data. I showed in other presentations how you do this kind of search so you can see in the past. So today you're not going to focus on this. So here in R Studio, how you run a row or a part of code, you can just select or just go to the row that you are and press Control Enter, and then you run the row that you are. So I ran this part of code. So I just imported the library quant-L in this time. Here, you're going to be updating all the libraries that you're going to be using for time series. This LubriDate is a library to take care of dates, to manage and processing date information. TimeTK, it's also the same producers of the model time. It's a time toolkit where you can do some plots. And Tsibble, it's a library to handle time series. So I'm just gonna load, oops, all of those libraries. And then you're gonna have this visualization library that's called Plotly. That's how you can create static and interactive plots in this one. And then the core ones, you're gonna use tidyverse for the data analysis and data preparation, tidyquant also for the data analysis, and some themes for our plots, and data table to deal with tables. And for modeling, you're going to be loading the tidy models. Tidy models just to have some functions that are going to be working together with the model time. And this model time.ensemble, because you're going to show how to average all your models in the end of the session. You're going to create different models for forecasting, and then you're going to average them. So just going to load all of them. So this quant-L.api key, that's the key that I was talking about, that you have to go there, register, and get a key. So it's free. You don't have to pay to use this data set. So if you have your own key, you just uncomment this line, and then you can add your key here between quotation. In my case, I saved this in my our environment. So I just need to get from my environment. So I'm just gonna comment here back. So here I'm gonna be loading my key now. Now I can use the command L. Here is the code for the price of the oil. So if I go there to the command L website and look for this, let me just go back there. And then I can search for this code. So we see that this is the code for WTI spot price. So it's a daily data set. And you see we have libraries that work in Python or in MATLAB. We are using this library in R, but if you have a prefer to use Python or MATLAB, you can do in both. And the way that you can download it, JSON, CSV, you can download it from here, or you can download it directly using those libraries in R or Python or MATLAB. So this is the daily data of the price of the oil that you're going to be downloading. No, I'm going back to the code now. So this is the code, the EIA, that's the energy institution in United States. So I'm just gonna save this variable here now. So I have this EIA underscore WTI. That's just the code. And here is the command L code that's gonna download the data. So we have to set what is the code that you are downloading. That's this EIA price of the oil. When you want to start, the starting date that you're going to be, the minimum date, and the end date, we are going to be setting for today. So this today, it's a command from the Lubri date. If you just run this, select this and run, you see that's going to plot the print here, today's date, November 19. And here just saying that we are ordering as ascending. So if you just run this piece of code, what we are going to be downloading is this information, is this array here, where we have the date and the price of the oil for each day. And here, I'm just sending a pipe and convert this as a table. So it's a type of a data frame, very powerful in R. So if I just run this piece of code, now I have a table where the first column, named the date, is in date format. So I have the dates, and the second column is the value. So it's the price of the oil. So now I'm gonna just save this as this WTI underscore prices. So if I just run this, again, I have the same table. And here I'm just using, this is from the time TK, just doing a plot of what is the time series. And those are some of the parameters that you can check. It's gonna show here on the side now that I run. And this is the plot. So it's gonna generate a plotly plot in here, and you can see all the values and all the information. So you can zoom in and check how is the price of the oil daily. So we have this negative day that it was in April 20th, that the price of oil it's almost minus $37 the barrel. So that was a good day to buy oil because you don't buy. They pay you to have oil. And they're going to be doing the study since the January 1st of 2020. So you can see there was a big drop at some point in 2020, and mostly because of the pandemic. And you can scroll here and see how was the behavior. Double click in the plot, and it should return to the original zoom. Also, another data set that you're going to be download is the production data, because they're going to be using both of them to calculate the impact analysis. And they're going to do the same way. The only difference is now you're going to change for the production code here, and they're going to be doing the start dates to be the same as the price of the oil, and also to be for today. So if we download this, so that's the data that we have. The difference of this data is that when we download it, this is the daily average per week. So it says that for that week, what was the daily average? So we're going to have to do some kind of processing to put them in the same time scale. And what you're going to do this, you're going to calculate what was the average per month in both scenarios. Okay, so you can assume that in 7 days here, the production was in barrel was 5,430 Ks barrels. So this is for per thousand of barrels. So we say that it's 5 million in the production, 5.5 million in this week. So that's the daily average. So here, I'm just gonna do the same type of plot, but now for the production. And that's how it goes. Um, so again, in the sometime in 2020, actually in April, we could say a little bit after in March, sorry, actually after the pandemic was declared to be global, we had a decrease of the production. But you're going to be doing for the whole 2020. You're going to assume that the whole 2020 was affected by the pandemic, not only from March 11, because many countries were already starting to have some lockdowns in the beginning of the year. Here, you're just going to be setting a function, creating a function that's going to change the time unit. So what you're going to be doing here, you're going to be receiving one of those data that has the date and the value. And then you're going to be calculating some type of function in here. So it's going to be a mean or something. You could select to be the median. And what is the time unit? So it's going to be the mean of the month. So here, the output is going to receive the data. And then you're going to mutate, where you're going to get the date to be the floor of the date. Means that for every month, every day is going to be moved to the first day of the month. So it's going to be January 2nd or January 10th or January 30th. All those information are going to be converted into January 1st. Then you're going to go group by date. So we're going to have all those days, they're going to be the same group. And then you're going to summarize, means that you're going to calculate the function that you're including here. In this case, it's going to be the mean, but you can select another one. So it's going to calculate the mean for this group, and then you just run group. So here we are just creating this, and now just going to show you the example how it works. So when you run this, now our data that was daily for the price of oil, now we have the average price for the month. So the average price of January 2005 was 46.8 barrels. So you're just gonna save this as another table in here, this WTI underscore price underscore month. And if we plot, you're gonna have a very similar plot that you had before. For the price, just it's gonna be a little smooth compared to the other one. And even the price is not negative anymore here, but it's just a very low price for this month. We're going to be doing the same for the production. So now we're going to have the average per month. So shown in here. So that was the daily average per month. And the other was the daily average of the price. And now we can compare them. They're both in the same time unit. And then you can start to work with them together. So this is also now the production plot. So it's going to be smooth. And something that you're going to be doing here is we're going to be running different models now for both situations, for the price and then for production, and see how each one of those models behave. And then you're going to stack them in the end to have a powerful prediction. And then you're going to do in the end, in the last part here, to do the impact analysis. So the first thing we're going to do to test our models, we're going to create a split. So we're going to separate whatever is test and train. So in our case, our test is going to be the last 11 months of our data set. So it's going to be the whole 2020 year, because you're in the month 11. So that's what you're going to do. You're going to do the predictions and then compare to what was the real value and then calculate the impact. So when you run this, we created this object here, that's the split price, that has some information. So if you look into here, so it's a list of 4, where you have the data, the index for the training set, the index for the testing sets, and some information as well, what's the type of data that we have in here. Basically, we have the whole data, and just in another list, the information that we have, what are the index for train, the index for testing. So here we're just going to be plotting it with this time tk function, and where we're going to be separating what is testing and training, and then you're going to pipe to the plot. So this is for the price. Oops, I think I didn't run this one completely. And now, okay. Oh, I know why, because I jumped to the production. So let's first plot the price of the oil. So this is gonna be our testing data. That's not be our testing. So this is the one that you're gonna be comparing with. And then you're gonna be calculating our forecasting for this part in here. And hopefully you're gonna get a higher value that we have, that's what actually happened. So the same for the production. We just created a split for the production for the same time period. So we can see that the production since 2012 was increasing with just a little decrease after 2015 and 16, but then it was with the trend to be increasing the production. So we are expecting that our forecasting models are going to create a model that's going to keep increasing. So we're going to see what was the impact if it was not for the pandemic. Probably the production would continue increasing, and the price, that's this plot here, probably would continue maybe with this trend of increasing, or at least more stable. So we have big drops due to the coronavirus. So a few models that you're going to be trying are the Arima, Arima plus XG boosting. Let me just show here. So we're going to try the Arima model. Actually, it's not Arima. It's going to, in some cases, it's going to be found as a Sarima. I'm going to use a library called AutoArima that is going to try to find what was the best combination of the Arima or Sarima, if you're going to have seasonality or not, and if you need to have moving averages, if you need to do some autoregressive and some differentiation. Then you're going to use a combination of Arima and XG boosting. Later, the Facebook Prophet, the Prophet plus the XG boosting. So the XG boosting, it's entered to do some predictions over the residuals of your data, of your forecasting compared to the testing. And then in the end, you're going to be ensemble all these 4 models, because you're going to see some models are more optimistic, others are more pessimistic. So you're going to create a model that's going to combine them, and it's going to be a little more robust prediction. Then you're going to do the forecasting for 2020 and end up with the impact analysis. So first, that's how we do in the model time or tidy models library, how to create a model. So we just, it's very similar to scikit-learn for Python. You just call what is the function that you want. So first, we want to do a Arima underscore regression. So this is from the model time library. What you want to do, we just have to set the engine from which library you want to run, because there are more than one Arima libraries that you can run in here. In this one, I'm selecting the AutoArima. So that's the computational engine. And here, I'm just fitting the data where we're gonna set the value in function of the date. So this till means in function of. And the data set that you're gonna be using is the training part. So this is from the model time or parsnip, this training, and the training part of our splits price. So when we run this one, we're going to create our model. So it's just running. It found a frequency of 12 observations per 1 year. So it found apparently seasonality of 1 year. But let's check the model. Okay, so that was the model that was created. So it was created an Arima 012, means that it didn't require any autoregressive, required one differentiation and two degrees of the moving average. And those are the coefficients that it calculated for this one. And it selected this model based on these metrics in here. So it tries different values and set the one that has the best metrics. We're going to do the same now for the production. So we create our predictions in here. So for the production, actually, it was a Sarima that it identified because we have this part more here. Sorry. So it was actually Sarima, where the Arima part, the non-seasonal parameters was 0, means no autoregression, 2 differentiations, and 1 moving average. And for the Sarima, for the seasonal part, it just required 1 autoregression and 1 degree of autoregression, and calculated that seasonality was 12 points. As we have our data in months scale, means that we have a seasonality of 12 months, or every year we see things start to repeating some part of the data. Now you're going to be calculating something, the Arima boosting. So this is just the auto Arima combined with the XG boosting. So this is just a little different how you do the function here. So it's value in function of the date plus a numeric date, because this second part here is for the XG boosting, and a factor. Factor means just the classes of the months. And here you're going to be running for the training data as well. So I called Barima prices because it's the boosted Arima. So I also found the observation of 12 points of observation per 1 year. So, and now it takes a little longer because it's also setting the XG boosting. We are just running with default parameters. You're not changing any parameters. You can change inside here your Arima boosting for both for the XG boosting and for the Arima models. And here you're going to check how the model was. So it's still running. So we have to wait a couple seconds more. Yeah. So what it created here, let's see, it created for the Arima part, it was a Sarima with the non-seasonality part with 3 autoregressive, 1 differentiation, and 1 moving average. For the seasonal part, only 2 moving averages and the seasonality of 12 months. And this is the XG boosting that we ran with those parameters in here. So we could change this parameter, change the max depth or the number of estimators or other things, but we just didn't do that because the defaults usually do a great job in this situation. So let's do the same for the production now. I'm going to calculate the XG boosting, the auto-rim and XG boosting, and see how was the model. That was a little faster. Also another Sarima with the non-seasonality, 2 differentiations and 1 moving average, and the seasonality part with 1 autoregressive and 1 moving average, and also 12 month seasonality, and the same XG boosting. Now we're going to be using the Facebook Prophet. This is another library. This is created by Facebook. So it's another way that it's calculated the seasonality and the trend and other combinations. So it separates seasonality by early seasonality, weekly seasonality, monthly seasonality, daily seasonality, and hourly seasonality. So it's gonna find for yourself by itself what is the best combination of seasonality that we have here. The only thing that I changed here was changing point range because it calculates the changing point where the trend changes. So it's gonna be between change points. The trend is gonna be linear, but it's gonna change only the slope. And the option in here, the default is 0.8. That's going to consider only 80% of the data to be changing, to be creating changing points. Here I say that it can create changing points until the end of the data. So just calling the Prophet regression. So I'm going to set the engine to be the Prophet and also the fitting in here. So it's going to be quite similar for the Prophet. And here you're going to see how the model was. So this is all the so it disable the weekly and daily seasonality because we have monthly data. So it recognized by itself, and then it's not calculating those. It's just calculate the monthly seasonality, yearly seasonality, and the trend. And I'm gonna do the same. And those are just the parameters that was select by default, and just the change point range. I select to 1, and the number of change points, the default was 25. So the maximum that you can have are 25 change points. So here I'm gonna be the same for the production, and then as we did for the Arima, you're gonna use the Prophet combined with the XG boosting. So it's something that it's a model that's gonna be used after to work with the um, residuals of the errors that we have here. So I'm just calling the Prophet as well with the XG boosting. So I'm gonna run for this one as well. And now here we are just gonna check and calculate the ensemble. So the first thing that you have to do to calculate the ensemble of these 4 methods, we have to use this model time table. This is from the library model time. So we're gonna include all our models inside here as it was a list of them. And here we are just doing the model tables, and we are sending to this function from the model time.ensemble, where we are going to be ensembling these 4 methods to create a new one, these ensemble prices. So this is what I'm doing for the prices, and the type of ensemble that I'm doing is the mean. I'm calculating the mean of the models. Okay, so here I'm just going to create a new table, model time table. Now I'm just going to be including these ensemble prices and the other 4. This is just going to be for plotting to compare them when I'm plotting. And then I'm going to be calibrating to the testing part or for the 2020 data. So I'm going to be calculating what should be the prediction. So I'm going to do the same for the production. I'm going to be assembling and create the new table. So now this is how we are going to be doing our forecasting. So we're going to get our calibration table, in this case of the prices. So, and then you're going to do here the model time forecast. So I'm just going to show you what is this calibration table prices, how it was created. So it created a table with the model specification. And inside here, we have the calibration data that is all the information that we have for the 2020. So that's why it's a table of 11 by 4. If we look here, so the calibration price, so it's going to be a list of 5 information, a lot of things inside here, and a lot of other things that you can use. So what you're going to be doing, you're going to be calculating the predictions for only for the testing part, and you're going to be using the actual data is going to be this one. So when you do that and plot the forecasting, you're going to plot for all our models together. And that's what we have. So I'm just going to be zooming in this area. So those are our models. We have this yellow one, that's the prophet, that was a little more pessimistic. We have this red one, it was the Arima one that created as Arima, so the prediction is strictly linear. We have this Arima with XG boosting. This light blue is the prophet with the XG boosting, and this darker blue is the ensemble. So I could say that the ensemble is the one that made the best predictions in this one. Looks like more in accordance to what we had in the past. All the others were a little bit more optimistic or pessimistic. So we're going to be doing the same now for the production. And let's plot and see what was the prediction for 2020. And here we have. So they are quite similar in this one of them. So just to keep with the same type of model as for the prices, we're going to keep the same model here. We're going to be using Ensemble. So we say that they're going to be better compared in this situation. Okay, so now what I'm going to be doing in here, I'm going to be separating whatever is the price, whatever is the production, and I'm going to be calculating in here, creating this new impact table with a table information. So first, I'm just going to get the unique for the forecast prices. What are the name of the models? So here we have those name of the models. So the model that we want to use is the okay, let me just check here. Okay, so what we are doing here, we are just selecting a few things. Let me just create these models. So the first thing we want to separate what is the actual, means the price without the predictions, what is the original price for the 2020. So here, you're just going to be selecting this part of the data. So we are selecting this where we have the model type is going to be the actual. The key is actual as well. So we're going to be using this column, and they're going to be extracting the index and the value. So those are the original ones for the whole date. So here I'm just selecting the columns that I want now. So now I just have a table with the index and the value. Now I'm just going to be renaming the index to date and the value to prices.t, that I say prices.true. So I just rename the columns, and then I'm just selecting the subset of the data where the date is larger than the last day of 2019. So our first date is going to be January. So we have now 11 rows. Those are all the monthly averages of the prices that we have for this year. And then I'm going to append with the same process that I did above, but only for the predictions. So we're going to use the model 6. So if you remember what are our models, our last model 6 is the ensemble one. So we're going to be appending this information. So when you run in here, I'm including now below, we have now the prices P also included in here. Then I'm gonna also be appending the the production information, the true one, and then also the predictions for the production. And here, just for better visualization, I'm converting to a table. So that's what we are extracting in here. So we have the true prices, the predicted prices, the true production, and the predicted production for the 2020. And then you're going to be mutating, I'm going to be creating these new columns where the revenue true is going to be the prices true times the production times 1000, because remember it was by 1000 barrels, the production. So that's going to be the average production, the average revenue per day in that month. You're going to do the same for the production, for the predictions, sorry. And then you're going to create a new column that says the days of the month. So it's not going to work, but it's going to create a column that's how many days have in that month. Then you're going to calculate the loss average, the loss cumulative, and the total loss that's going to be multiplied by the number of days of the month. So what are the total loss for January is going to be multiplied by 31 because there are 31 days in January. And then the cumulative loss, that's just the cumulative sum of the total. So when you run this, we're going to be creating this impact table. To just make this one a little larger, that has this information. So we have the date, all the true and prediction values. So we have the true revenue that was multiplied by 1000, remember? So that's the average revenue. That's the average production, the days of the month. So this is the loss, the total loss, and should have another column, the loss cumulative. So if you want to look better to this table, I'm just going to click in this one. So you're going to be viewing the impact in here. So that's the information that we have here. So you're going to be plotting this total loss and the cumulative loss. So just going to be doing now this plot in here, where I'm going to create a plotly, where I'm going to be adding the cumulative loss, the monthly loss, each one with plotting in here, and some information. So when I plot this one here, I'm just going to increase now the figure size. So that was the loss of the oil industry in 2020 in the United States only. So in orange, we have the total loss per month. So for example, in April, that was the month that the United States has the biggest loss, was something around $17.7 billion. And in November is actually a prediction because we still didn't finish November. So in November, we're going to be predicting to have a loss of $10 billion. And the cumulative loss until the end of November is predicted to be $108 billion, almost $110 billion only in the United States due to the COVID-19. So that's how we did the impact analysis. Going back to the presentation. So just some closing notes for today. So now it was the last one of the year. So we're going to be returning in sometime in January 21. Okay, so if you have any questions, you can just unmute your mic and video and ask. Thank you. I see a clapping.
Marcelo, I have a question that it was a bit back when you explained the Arima prediction and the autoregressive component was 0. So when you have if you don't have an Arima, you have an Arma that is without the I for integration. So in that case, if the autoregressive component is equal to 0, it means that really there is no correlation with the past, right? So in a way, it means that your modeling cannot find any connection between a past value and the future. Is a little like saying that it's unpredictable, or there are some coefficients that can predict if with the moving average part, right? That is really a random input. So does the integration part account for
to make the time series to be stationary?
mhm.
So to remove the trend.
Okay.
So
Right.
the Arima only works when we don't have trend. So it calculates differentiations, how many times you have to do calculate the differentiation. In this case, it was 1 to remove the trend. And the integrated part means because after you do the predictions, you do an integration.
Right. Right. But so what does it mean that in this context, what's your interpretation of the fact that the autoregressive is 0? Does it give you any
Well, for this one, my interpretation is just the one that had the best just the best metrics for some way where they are doing the testing inside here. So they selected subset inside here. So they try different ones and got to this one. So you can see that there is a confusion because when I use with the XG boosting, if I
mhm,
remember well, it required 3
mhm.
uh, autoregressive.
Right.
So there is a past component there. It's
Mhm,
just the way the data set is. It's you know that the oil industry we depend of the past, but also for external components,
mhm.
external variables. As we are not including these external variables, we might create these nasty models.
Right, right, right. And the other thing, I don't know if you, maybe I missed it. Did you explain the ensemble method, how it works?
The ensemble, I just say that it's calculating the mean of each one of them.
Oh, okay.
So just the mean
Right,
of
right,
the predictions.
right.
But
So even
is it, oh, sorry. Is it
go
is
on.
it actually giving some different weights between the different models, or is just plain average?
It's just plain average. You can include some weights if you want. In this case, I just did the simplest one, but there is a way to also, if we look here to the ensemble, oops, to the ensemble average. So I'm pretty sure you can give weights. No, actually not. You can select the mean or the median. But I think there is another one that's the ensemble weights. Yeah, you have another one named the ensemble weighted. So then you can give the loadings are a vector of weights corresponding to each one of them. So it's basically it's going to calculate an average weighted by each one of them.
Okay, great. Thank you.
Any other question? Okay, if you don't have any more questions, so I'm gonna stop the sharing. So I'm gonna be thank you all for joining. So just repeating, today is the last lab of the year. So we're gonna be seeing you again next year in January. So stay tuned. We are gonna be sharing in the cruise website and on LinkedIn all the information from the next lab. So thank you and happy holidays for you.
Thank you. Happy holidays too. Bye.